Yes children, now we will do rest of the questions from your exemplar book. Okay. In question number 25, you have to write balanced chemical equation for following reactions. So let's see what is given in the first question. In this, sodium carbonate on reaction with hydrochloric acid. Okay, so you should know what is the molecular formula for sodium carbonate. Sodium carbonate is written as, I'll write it for you. Sodium carbonate is, you have to write the symbol for sodium, that is Na. Okay, this is N, fine. Na2CO3. Okay, this is sodium carbonate. When it reacts with hydrochloric acid, that is HCl, okay, it gives, and they have given that they are reacting in equal molar concentration, fine. So number of moles is going to remain the same. So let's see, we will do balancing also later on. Right now we will keep it as 1 molar only. Okay, 1 molar concentration of sodium carbonate with 1 molar concentration of HCl. Okay, so Na2CO3 plus HCl, it gives you sodium chloride and sodium hydrogen carbonate. Sodium chloride is NaCl, okay, with sodium hydrogen carbonate. How you write sodium hydrogen carbonate? You have to just keep writing the symbol. Sodium symbol is Na followed by hydrogen, and for carbonate it is CO3. Okay, so once you have done this, just see that number of atoms in reactant and product, is it same or not. Okay, if you see here, sodium atoms are 2 in number in the reactant, and in product also there are 2 sodium atoms. Carbon is 1, and in product also it is 1. Oxygen, if you see, it's 3. In product also it is 3, right? Hydrogen is 1 over here. Here also it is 1, and chlorine is also same in number. So number of atoms in reactants and products, they are quite balanced. So we don't have to make any change. Okay, this reaction is a balanced reaction now. Okay, now moving on to the next question. In the next question, it is given that sodium hydrogen carbonate, that is NaH. Okay, just now we wrote the molecular formula for sodium hydrogen carbonate. Sodium symbol is Na. Okay, sodium, then followed by hydrogen, and then carbonate is CO3. Okay, so NaHCO3, when it is reacting on reaction with hydrochloric acid, okay, HCl, this is H, okay, HCl, keep it straight, HCl, it will give sodium chloride, water, and liberates carbon dioxide. What it is giving? It is giving sodium chloride, that is NaCl, and water, that is H2O, and it is liberating some carbon dioxide. Okay, so CO2. Okay, make the correction over here, this is CO2. Okay, so once you have written this, just check whether number of atoms in the reactants and the products, okay, for each element, is it same or not, and you will see that it is same. In this reaction also it is same. Okay, number of sodium atom, for hydrogen also it is same, 2 atoms are there, chlorine is 1, oxygen is 3 in number. Over here also there are 3, they are altogether 3. Okay, so it is a balanced equation, fine. After this, do the next one. Let's see, it is given copper sulfate on treatment with potassium iodide. Copper sulfate is what? Copper sulfate, molecular formula, how will you write? Copper symbol is Cu, sulfate is SO4. Okay, so CuSO4 is reacting with potassium iodide, means K is a symbol for potassium and I is for iodine. So potassium iodide, when they react, it will give what? It is giving the precipitate of cuprous iodide. Cuprous iodide precipitate is formed. Okay, and its molecular formula is also given here, but you can remember it is Cu2I2. Okay, cuprous iodide is formed, and it also liberates iodine gas, right? So iodine, as I told you, it is a diatomic, so here it will be I2, iodine gas, and also forms potassium sulfate. Potassium sulfate is, potassium symbol is K, and then sulfate we write it as SO4, right? Thereafter you have to write the valency also. So potassium valency is 1, so you need not write it next to sulfate. Okay, no need to write. and for sulfate valency is 2, so 2 will come here, okay, next to here, okay. So K2SO4, okay, just check here, K2SO4, this is how you have to write it, K2SO4, okay, because sulfate valency is 2, so it will become K2SO4, that is potassium sulfate which is being formed. Fine. Now if you see the balancing part, I'll just write it again. If you see the balancing part in this, you see here that copper is in the reactant, it is just one atom of copper, whereas in the product we are getting 2 atoms of copper, right, over here. So here also we need to make it 2, so we'll add number 2 here, fine, in front of copper sulfate. Now let's see that in sulfur, number of atoms of sulfur has become 2 now in the reactant. In copper sulfate there are 2 sulfur atoms, and in the product, okay, here is the sulfur with K2SO4, it is only 1 in number, so we need to make that also as 2, so we'll add 2 over here. Now moving on to oxygen, oxygen is 4, and here we see in the product it is 8 in numbers, right, here it is given 4, so 2 moles of K2SO4 are there, so 4 to the 8 atoms of oxygen are present in the product. And in the reactant also you see it is not just 4, it is 4 to the 8, because we have already added 2, so here also it is 8. So oxygen we need not balance. Now potassium, if we see in reactant it is only 1, whereas in product it is 2 to the 4 atoms of potassium are present, so here also we need to balance it by adding number 4, fine. Then you see that for iodine number is here. In copper iodide we see there are 2 atoms of iodine, also there is iodine gas which is being liberated, so it is in diatomic state I2, so these both become how many atoms, 4 atoms of iodine, and in reactant also there are 4 atoms of iodine, okay, over here you can see. So with this the reaction is balanced, fine. So overall reaction will be 2CuSO4 plus 4Ki will give you Cu2I2 plus 2K2SO4 plus I2, okay. Now let us do the next one. It is given that there is a solution of potassium chloride when it is mixed with silver nitrate solution, an insoluble white substance is formed. Write the chemical reaction involved and also mention the type of chemical reaction, okay. So in this type of question what you have to do, first you will write the chemical reaction and thereafter you decide which type of reaction it is, and then make sure that you have balanced the equation, okay. So in this let us write the reaction first. Potassium chloride is written as potassium symbol you will write, followed by chloride is Cl, so it becomes KCl is reacting with silver nitrate, that is silver symbol is Ag, okay. So AgNO3 is silver nitrate, fine. When they react, what it will give? It will give us the precipitate of AgCl will be formed. It's a white color precipitate which is formed of silver chloride, and KNO3, that is potassium nitrate, is also formed, okay. So if you see it is a precipitate, so you can show it by putting an arrow downward, fine. So AgCl is a precipitate which is formed when the potassium chloride is reacting with silver nitrate, okay. So what type of reaction it is? If you see, it is like KCl is breaking from here and AgNO3 breaks from here. Ag is going with Cl, so it forms AgCl, right? The silver chloride is formed when these two are combining, whereas potassium is going along with the nitrate ion, so it forms KNO3, okay. Another way is you have to understand that potassium chloride in its aqueous state will form 2 ions, one is the positive and negative ion, potassium K plus ion will be formed and Cl minus ion will be formed, right. Similarly for AgNO3 it will be Ag plus ion and NO3 minus 2 ion, so negative charges will move towards the positive and the positive will move towards the negative and the bond will be formed, and this is how the reaction take place. and because the displacement is taking place with both the reactants, okay, KCl and AgNO3, these are the two reactants we have here. So in both of them there is a displacement taking place, so we can call this as a double displacement reaction. Also it is a precipitation reaction because AgCl as a precipitate is formed. Fine. So type of reaction is double displacement and precipitation reaction. Okay. Now let us do the next question, that is question number 27. Ferrous sulfate decomposes with the evolution of gas having a characteristic order of burning sulfur. Write the chemical reaction involved and identify the type of reaction. So again you have to write the chemical reaction. Ferrous sulfate is what? It is FeSO4, right? So ferrous sulfate, how will you write? You will write Fe, ferrous sulfate, FeSO4. This is our ferrous sulfate. It is getting decomposed with the evolution of gas. So decomposition will involve, it will take up some heat and will get decomposed, right? So here what you have to write, you will write heat. Okay, it will take some heat, so it's a kind of endothermic reaction. It is taking heat, and thereafter what is happening? There is evolution of gas having characteristic order of burning sulfur. Okay, so a gas is evolved which will have the order means here order means smell of burning sulfur. Fine. So what will be formed in this case? So it is actually what is formed is Fe2O3 is formed. Also what is formed is SO2 and SO3. Fine. So the sulfur burning sulfur's smell comes because of the sulfate, okay, sulfur dioxide and sulfur trioxide. Because of that smell comes, and we have to now check whether it is a balanced equation or not. Fe is number of atom of Fe in product is 2, whereas in reactant it is only 1, so we will make it 2 by putting 2 over here. Fine. Now let us check for the rest. Sulfur in reactant it is 2, whereas in product it is also 2. For oxygen it is 8, and in product also it is, if you add all, it will come to 3 plus 3, 6, 7, 8. 8 is there. Okay. So oxygen is also 8 in number. Fine. So it is a balanced equation now. And what else is asked is the type of reaction. So if you see here, it is a kind of thermal decomposition, because thermal we use for the because heat is being supplied or heat is being consumed in the process. So it is a kind of thermal decomposition. It is getting decomposed. So we can use the word thermal decomposition. On heating, the ferrous sulfate is getting decomposed into iron oxide, sulfur dioxide and sulfur trioxide. Okay. Now moving on to the next question, that is, why do fireflies glow at night? Yes, why fireflies will glow at night? Fireflies have a protein. Okay, fireflies have got protein in them. Okay, they have protein which in the presence of an enzyme will undergo aerial oxidation, means they will undergo oxidation. That protein will undergo oxidation, okay, in the presence of an enzyme. Fine. It is undergoing, so there is a protein which undergoes oxidation, and this is a chemical reaction which involves emission of visible light. So that protein, when it undergoes oxidation, it produces some light, okay, that is visible light which can be seen, and that is the reason why we see that fireflies glow at night. Okay, so this is the reason. So the protein which is present in them is getting it's undergoing oxidation. Fine. And because of that it evolves light. Okay, now moving on to the next one, that is, grapes hanging on the plant do not ferment, but after being plucked from the plant can be fermented. Under what conditions do these grapes ferment? Is it chemical or is it a physical change? So in this question, if you see, grapes when they are attached to the plants are living, right, and their own immune system prevents fermentation. Okay, so in this question when they are asking that under what condition these grapes ferment, so when till the time they are attached to the plant they are getting nutrition, their immunity is quite strong, but the moment they moment they are detached, when they are removed from the plant, what happens? They lose their immunity. Okay, and because of the loss of immunity, they are attacked by the microbes, and the microbes start growing on them, and once they are plucked, the microbes grow in them under anaerobic condition, and it causes fermentation. So it is a kind of chemical change. What type of change is taking place? It's a fermenting. Okay, fermentation is a type of chemical change. Fine. So now moving on to the next one. Which among the following are physical or chemical change? So evaporation of petrol. Evaporation of petrol, what kind of change it is? Evaporation of petrol, it is a kind of physical change. Okay, burning of LPG is a chemical change. Okay, I'll keep writing for here. This is a physical change, whereas burning of LPG is a chemical change. Heating of an iron rod to red hot is an example of, again, it's a kind of physical change. Only change in the shape and size is there. Okay, heating does not mean that there is any chemical change is not taking place as such. Curdling of milk, again, yes, it's a chemical change. And sublimation of solid ammonium chloride is a type of physical change. Okay, sublimation of solid ammonium chloride is physical change. Okay, now let's go to the next question, that is question number 31. During the reaction of some metals with dilute hydrochloric acid, following observation were observed. What was observed? That the silver metal does not show any change. Okay. Second, it was observed that the temperature of the reaction mixture rises when aluminum is added. Next, that the reaction of the sodium metal is found to be highly explosive, and some bubbles of a gas are seen when lead is reacted with acid. Explain these observations giving suitable examples. Okay, so quite a lengthy question. I'll explain you in parts. Okay, what is being asked actually. Okay, so in the first part, if you see, if silver metal, okay, is not showing any change, it tells that silver is a noble metal. It lies between hydrogen in the reactivity series. Sorry, it lies below hydrogen in the reactivity series. Fine. Now because it is below hydrogen in the reactivity series, it is one of the noble metal. Okay, hence it does not react with hydrochloric acid. So it is not reacting, there is no change. If you put hydrochloric acid to silver, it is not reactive, it will not react with hydrochloric acid. Now moving on to the next question, that is the temperature of the reaction mixture rises when the aluminum is added. So what will happen if it is like this is the observation actually, that the temperature is increasing. So there is the metal is aluminium now. Okay, so to the aluminium metal, when we are adding dilute hydrochloric acid, some heat will be evolved. Okay, in this case some heat will be evolved, so it is a kind of exothermic reaction. Okay, so so during what you have to tell basically the reason. Okay, one second. If you see in this question, explain this observation giving suitable reason. So like in the first one, as we saw that silver is a noble metal, so it is not reacting. That was the reason why it does not show any change. Similarly, in the second one, what is happening here, that the temperature is rising. Okay, it is given that temperature is rising. Why it is rising? You have to give reason for it. So reason for it is that there is a heat which is being liberated out. Okay, because of the liberation of heat, the temperature has rose. Okay, now moving on to the next question, the reaction of sodium metal is found to be highly explosive. Okay, so we have to give reason for it, why the reaction with the sodium is highly explosive. So the reason behind it is that sodium is very reactive metal. It reacts with dilute hydrochloric acid vigorously, and a large amount of heat is given out. Hence it is highly explosive. Okay, moving on to the next question, some bubbles of a gas are seen when the lead is reacted with the acid. Okay, so suppose lead is reacting with acid, let's say our acid is, in this case it is already given that it is hydrochloric acid. Okay, so when it is reacting with hydrochloric acid, what is happening here, that it is if you see, lead is here our metal is lead. Okay, lead is above hydrogen in the reactivity series, so it is more reactive, thus some bubbles of hydrogen gas are produced. Okay, so hydrogen gas bubbles are being produced because this lead is slightly more reactive. Okay, comparatively it is more reactive, thus this lead is reacting with hydrochloric acid to give hydrogen gas or H2 gas. Okay, so I'll just stop here, and few more questions I will discuss in the next video.